Welcome to lumaj chemistry, organic chemistry class. In our last classes, we have dealt with alkane. We did introduction into organic chemistry, and I told us there that we have um, aliphatic. We have hydrocarbon under it. Talk about aliphatic hydrocarbon. We have aromatic hydrocarbon. Under aliphatic hydrocarbon, we have acyclic aliphatic hydrocarbon. Then we have the cyclic aliphatic hydrocarbon. In some textbook, they can tell you that we have unsaturated and saturated. That's how to differentiate between alkene and alkyne. Because I want to talk about alkene today. Because I will need maybe another video. We talk about the reactions of alkene, and alkyne. But let me just first explain the principle, how to name them, how you can easily play around these what do you call it, aliphatic or generally hydrocarbons. Then we'll now start talking about their reactions. Yeah, let's talk about alkene today. Alkenes. Don't forget, I said in your alkane, your methane, your ethane, your propane, your butane, they are gases. The first thing that will come out when you are doing what we call fractional distillation of petroleum. I said petroleum, or you call it crude oil, or you call it rock oil, or you call it black gold. So when you do their fractional distillation, the first thing that will come out are the gases, then followed by the volatile liquids. The mention of diethyl ether, then we have petrol. You know, when you touch petrol, it will be so cold. After a while, everything will disappear, showing that it is very volatile. That is why it's very easy for petrol to easily burn houses. Then we also have kerosene. There is also liquid, but it's not as volatile as your kerosene, as well as your petrol. Then we have your diesel. Then from diesel, we talk about the oil, the lubricating oil. Then we have the bitumen, and so on and so forth. Today I will talk about alkanes. The way we have done for alkane, we are going to do this also. So this one is an unsaturated hydrocarbon, while your alkane is saturated hydrocarbon. Here we have two bonds. In alkanes, there are two bonds. Two bonds. Don't forget. Carbon to carbon. Here we have carbon to carbon double bond. In alkane, you know, when I say you have, let's say C2H6, that is the molecular formula of what? Ethane. For you to write the structural formula of this, you first of all have carbon to carbon single bond. Carbon to carbon single bond. Then obeying the law of tetravalency, you can see this. You say this carbon is what? Saturated. It is saturated. You cannot break it further. It is already saturated. No any other pi bond that you can easily break. But under alkanes, we have carbon to carbon double bond. So we call it the functional group. This is the functional group. Carbon to carbon double bond. So that will differentiate alkane from alkane. In alkene, we have carbon to carbon double bond. So the molecular formula of alkenes is H2N alkane, Cn H2N plus 2, alkyl, Cn H2N plus 1. Now we have this functional group. Don't forget law of tetravalency. Four bonds must surround your carbon atom. We have 1, 2 for this carbon, 3, 4. Some textbooks are writing this way, whichever way. Whichever, it has to be 4. It has to be 4. It has to be 4. 4 bonds surrounding the carbon atom. 4 bonds surrounding the carbon atom. 4 bonds surrounding the carbon atom. Don't forget the way we said the other time. We have the serial number. We want to know their names, their molecular formula, chemical names, molecular formula, then the structural formula. Let me use SF. So here we say when n is equal to 1. Don't forget n is greater than or equal to 1. When n is equal to 1, we have here it will be when n is equal or greater to 2. We have C2 H2 into bracket 2. C2 H2 into bracket 2. We have C2 H4. C2 H4. So for us to add this, we're going to have the molecular formula, which the first one is going to be 1. Instead of we having met A, there is nothing like met in. No. The first one we're going to have is ethene. Don't forget the last word, E-N-E. Ethene. Gotten from this E-N-E of arc-in. We have E-N-E. Ethene is the first that we heard. And ethene is a gas. In some terms, we call it ethylene. So it's still the same thing. We have ethene. So the molecular formula is going to be C2H4. Or you could split this one down. Let's see from the structural formula. Carbon to carbon double bond. You know, when we're writing it A, we wrote carbon to carbon single bond. But here is carbon to carbon double bond. This is a single bond. This is a single bond. This is a pi bond. Meaning that this pi bond can be broken in a chemical reaction. So let's complete it. This is 1, 2, 3, 4. 1, 2, 3, 4 for this carbon atom. How many hydrogen do we have? This is 1, 2, 3, 4. So if you want to clamp this, the way we said it in Arc A, we can say this is H2, 2 hydrogen, C. Then we have this C, H2. I think that is clear enough. You can have, is that you write C2H4 or you write CH2 double bond CH2. Once you see double bonds, you are talking about what? Arc-in group. You can do the same thing from 2 that we have pro-in. 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 So for pro-in now, that will be n equals to what? Greater than equal to 3. So put 3 in this equation. You have C3 H2 into bracket 3. So you're going to have C3, 2 times 3, that's 6, H6. The first thing you're going to write is your carbon to carbon double bond. That is, you have used 2 carbons, remaining 1 left. It's either you add it to the front or you add it to the back. Let's add it to the back. We have this. This is now 1, 2, 3. Add law of, don't forget the law of tetravalency. For this carbon, okay, let me start with this. For this carbon, this is 1, 2, 3, 4. For this carbon, 1, 2, 3, 4. For this carbon now, 1, 2, 3, 4. So let's just add. Hydrogen, 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 hydrogen. If you count down, this is 1, 2, 3, 4, 5, 6. What do you have here? C3H6. So the structural formula of propene, which is 3, is what? C, double bond C, with this hydrogen. So for us to write the molecular formula now, we have H3C. H3C. We have CH, then we have double bonds. Can you see? This is your pi bond, this is your sigma bond, then CH2. Is it clear? So is that you write it this way? Some textbooks may write as CH3, CH, double bond, CH2. What is important is that all the carbon must be surrounded with 4 bonds. That one is very, very essential. They must obey the law of tetravalency. In the naming of arc-in, I will explain expressly again how you know whether this one is going to be prop-1-in whether it's going to be boot 1 in, whether it's going to be boot 2 in, whether it's going to be pen 1 in, pen 2 in. You don't need to bother yourself. It's very, very simple. Just understand the principle. Like I said, principle is universal. Whatever I teach here, if you apply it in Kenya, if you apply it in Gambia, you are going to have the same results. I'm here in Nigeria explaining it. Even if you are watching in South Africa, if you apply this, we are going to have the same results. So please subscribe to this channel, share this to your friends, your classmates, and make sure you like this video. If it's interesting to you, let me know in the comment section. If you have any problem, let me know. I'm available to attend to any garden problems you think you're having in chemistry. So this one will be for Arcane. For reactions in Arcane, that will be in another video. I'm going to do that. So day after this, we move to Arcane. So in Arcane, I will explain the same way I've done here. They will not do reactions of all. I think that is clear. Thank you very much for watching this video. God bless you all.